Okay, good morning, everybody. We are Team 5. I'm Nick. This is Kevin. This is Akash, and that is Caleb. And today we will be presenting the Copter Ball 2000. Right now we are going to just kind of show you just the background story of our idea. Okay, there we go. A long time ago. In the year 2036, the space station Copter Ball 2000 is on a collision course with an unknown planet. In order to save themselves, the crew members must flee on the last remaining escape pod. Will they make it in time?
So the idea behind the toy is you have a ball with a wing on it, and you basically first wind up the wings, and then you drop the ball, and then the wings fly off. So basically that's how it works. And the wing itself is the escape pod that flies off the spacecraft. So how does it work? First, I'll go to the inspiration.
So we looked at a couple of the toys that are out in the market, and we wanted to come up with something different that like the kids could play. Some of the inspiration ideas were with this toy with like a spinning shaft where you just have the wings on top and then you turn it and then it flies off. The second one is just the escape pod, which our theme goes from. And then the third toy that you see here is a helicopter inside of a ball that you can actually control, and it flies. And if it hits the ground, then it'll start rolling. So these are some of the toys that are out there that we looked at in order making our toy. Here you go.
All right, so you can see here in the picture, it's just like a rendering of our toy. We did using CAD software. And I'll go to this picture here. Here's kind of like the inner mechanism of our toy. And we'll go later on into the power mechanism and the release mechanism. But just kind of a summary of how the toy works. When it hits the ground, this button gets pushed up, and these linkages here control these L pieces. And in the neutral position, these L pieces are connected into these notches of the hub of the wings. And when it hits the ground, the button pushes up, it releases, and the stored energy of the spring gets released, and the wings should fly off, theoretically.
This is the bill of materials that we use for this project. One of the most interesting things to note is that everything but the wings and the bolts are made from SLA material using the 3D printer here at Purdue. We got the rest of the stuff just through sites like McMaster, and we got the wings through a third-party source.
All right, so there's two mechanisms to the toy. There's first the power mechanism, and there's the release mechanism. So how the power mechanism works is there is a prop shaft right here, as you can see, which is held by bushing right here. And then there's a pulley and a spring. So the spring is obviously the power. So the spring is first fixed to the shaft right here, and then there's a string attached to that which goes around the pulley around the prop shaft. So basically when you wind the prop shaft, it winds it more and more, and when you release it, the spring pulls together and then it spins the shaft. And here's another picture of it. As you can see, there's a hole in the prop shaft where the string goes through, and then it winds it around.
So once you spin the hub, we had to come up with a locking mechanism. And the way that works is that when the button is out in its first position, this is a 4-bar linkage that keeps it pressed in. There's these grooves cut out in the hub that holds it in. And once it hits the ground or any impact force, the button will get pushed up and the links will rotate. These two links pivot around here, and that's what allows it to come out, and then it will spin the other way. So I'll show you a before after. Dang this person. So that's how it works. That's the first position, and then when it hits the ground, the 4-bar linkages will come out, and then the hub will fly out.
All right, well, we're almost out of time, but we're looking at age range of about 8 and up, because setting the toy up when you actually use it is kind of a difficult means. So we're looking for about 8 as the age of kids that could probably do it on their own. We're theoretically looking for neutral gender, but probably more towards guys with this spaceship idea. But in terms of marketability, we could expand it to maybe fairies flying or something to include some of the female market.
Okay, the last thing before we wrap this up is this is a proof of concept model that we're using right now. In the final model, we're going to have a rubbery material on the outside so that it will help reduce impact force and maybe even provide a little bit of a bounce to kind of help eject the escape pod from the rest of the mechanism. And like Caleb was saying, we can use different paint schemes and stuff for different marketing, and even change the wing type to maybe help it fly differently.
And I'm not going to bounce it on the ground right now just because it's SLA and we don't have any protective material at the moment. But as it hits this button, it should fly off, as you can see. Yeah, if my finger didn't hit it.
As you can see right here, you can see that when you press the button, there's a release mechanism that comes out, and there's grooves on the hub itself, like explained, which locks it in. So that's it. Yeah. Any questions?
Do you feel there's anything in the design that's innovative or?
I think we feel that the whole integration as well as the power and release mechanism is kind of innovative. As you can see from the inside, you can see all the springs and stuff working. And it's a pretty cool mechanism of how everything ties together.
And we wanted to like keep it all mechanical. We didn't want to go through the electrical route because we could have come up with something for the release mechanism in terms of like electrical, but it just works with 4 bars and springs. So yes.
Have you considered the flight path of the rotor?
That is one thing we have not considered. So we didn't go too much into details about calculating what sort of wings we should use, what angles we should use, what sort of geometry we should use for the wings.
Right. Do you see what I'm getting at? Can you imagine a kid dropping it and the first thing it does is it pops off and hits it in the face?
That is a possibility.
That's why they're wearing glasses.
Exactly. That's how it.
I like the fact that it's mechanical and you created a real interesting device to wind it up and it operates without any power.
Thank you.
Does it have to drop right on the button? I mean, part of it is, do you expect to, or did you intend that to be used as sort of a ball, or no, in terms of, I guess my question is, how does it end up on the button? Does it, like a crazy 6-year-old just run around and throws it? And 8-year-old, sorry.
Our original design was a perfect hemisphere, but we were actually getting pretty close on material. We had a limit on the material we could use, so we made it towards more of a bullet design, just to save on some material. And theoretically, if the bottom were weighted, if we were gonna mass produce this, we'd weight the bottom so it would fall theoretically perfectly on the bottom. The button's pretty big, so it doesn't have to hit it perfectly on the bottom. So
Right there.
If it even like rolls off and hits the button, wings will still come out.
Can you show us how you wind it up?
Yeah, so you can see the prop trap here where if you
Can
wind
you actually do it?
Oh yeah. So what you gotta do is you gotta press the button, hold the button down so that the links are out,
Yeah.
and then you basically twist the hub until a certain preload until actually the spring hits the pulley, and then you let go of the button so then the latches go back in and hits the little notches around the hub. So there's little notches spaced out on the hub where the links basically lock into. As you can
Then
see
when
right
it hits the ground, it should fly off.
So we're a little scared to wind it actually all the way since it's SOA and there's very small parts in there that's
Yeah.
broken before. So we're kind of wary on how much we should wind it.
Plus, it has a lot to do with like the design of the wings. These are actually from an RC helicopter, and in order to get enough force lift, it needs to run at huge RPMs. Which we can't really get out of spring unless we like really crank this up. But even then. So.
Thank you.